Hi, my name is Soni Midha, and I am a virtual content specialist for Algebra 2. And so today I'm going to be talking about the warm-up activity for Unit 6, Day 18. How do we identify the amplitude of trigonometric functions? Now, this is actually a two-part, two-day lesson, and the goal of it is really to introduce to our students the midline and the amplitude of trigonometric functions. More specifically, the goal of this launch activity, this warm-up, is really for students to, recall the effects of vertical translations and stretches in quadratic functions, which is, something that they're very used to seeing. So really using quadratic functions to help them get ready for transformations effects on trigonometric functions. So the activity is asking students essentially just to, look at a couple of equations and graphs and really match them accordingly, right? Which equation matches to which graph. And I think the best way that we can do this virtually is using Desmos with a card sort and then just adding a text layer to explain their thinking. So I'm going to go ahead and just show you what that might look like. Here you'll notice that I really just sort of set the stage by putting the graph of y equals x squared in there just by clicking the graph button and then adding a note saying the following graph represents the function y equals x squared. Using this as a guide, match each question to their graph on the following slide. And just a reminder, when you click preview, you'll be able to see exactly what the students will see. Now, for this activity, again, I highly recommend just doing a quick card sort. This card sort is actually a little bit easier to make in the sense that you don't need to drag any images in, because really all you have to do to put your graphs in is just, once you've clicked card sort, then you'll notice that you've got three options. And so if you just click graph, you can literally just write in the equation itself that you want to have as part of this warm-up. So I just wrote y equals 3x squared because that is one of the options. I click large card, and then if you go to preview, you'll notice that it's just the graph, right? It's just the graph. They don't actually show the equation. So I want to do this for all four of my graphs, and I also want to write the equations down. And to write the equation, I will click on math or text. And because I want it to be in a nice math type, I would click on this little symbol right here, this radical symbol, type math, and I would simply just write y equals 3x squared. So I would click large card. Again, the large card is not mandatory, but it does kind of help students see these images better. So you want to do this for all four equations, both the four graphs and both the four actual equations, and then that'll be your card sort for your warm-up. One thing to note, I've gone ahead and just made them for all the graphs and equations here. One thing to note is that you can always put in the answer key, and I highly recommend it for a situation like this, so you can see if students are getting it right in real time. And to do that, you just click on answer key, and you're just going to move the equations. You're going to sort it yourself, really. And so if I look at this, I know that 3x squared is going to go into this equation right here, this graph right here. And I can see x squared minus 1. So you're really just going to be moving these around the way that the students would, but having this done ahead of time. So you just click done, and literally the key is there. So when you're on the teacher dashboard, you can see which ones students are getting correct or how many they're getting correct. So that's the first part of the warm-up. And again, this is a really great way to get them ready to look at the transformation, specifically midline and then later amplitude for trigonometric functions. But you also want to have them explain their reasoning, right? How do they know which graph belong to each equation? So I think a really great tool that you can use is just adding a little bit of a prompt for them to answer these questions using this computational layer in Desmos. And so what you'll notice that I've done here, it has the graph of y equals 3x squared. And it's just a blank text box. But if I go to preview, you'll notice that there's actual words in there. And it's really just basically providing students with text to begin their sentence with, right? So the equation I chose for this graph, they would write y equals x to the third here, and then they would write why they chose it after the because. And of course, you can change the wording for this, whatever you think makes the most sense for your students. But in order to build this, you're just going to go ahead and insert a text box, but you're going to go ahead and click on this button right here. This is the computation layer. And I know it's kind of intimidating, but this is actually a pretty quick code that you can use. If you just click on it, I've already gone ahead and done this here. you'll notice that it says initial text. Initial, the I has to be lowercase and the T has to be uppercase. You write colon and then you just put a quotation and you literally write exactly what you want students to see in that box, right? Again, the text to get them ready to explain their reasoning. And so this is a great tool that you can use to get students to start writing. You can do this in one whole slide, so you can have all 4 of your graphs in one slide, or you can create more and more and more slides for each graph. That's a matter of how you want the activity to look. But just keep in mind some sample explanations that you'll get, right? So with y equals 3x squared, and also, of course, y equals x squared, students might say, oh, when x is 0, they both take the value, y equals 0. And they could also say something about one has a steeper graph than the other. Another thing they might say is, the equations y equals x squared minus 1 and y equals 3x squared minus 1, they both take the value of -1, right? So just some things to keep in mind. They take the value of -1 when x is 0, of course, and they have a steeper graph. So again, this word steep, you definitely want to hear from your students. So those are a couple of things that you might hear them say. They could also say something about y equals 3 parentheses x minus 1 squared, something about how the vertex has been moved a certain way. And what I definitely would say is that, like, if they're having trouble, really encourage them to sort of refine their descriptions using more precise language, and essentially just like connecting it with work they've done before, right? They've done quadratic functions before. They know what that's all about. So you can really, ask students, well, hey, what other transformations do you know about? Have we learned about that use the value of 1 and 3, right? Starting with the function 3x squared, how can we transform the function how can we transform the function y equals x squared into a new equation with a value of 1 and 3, right? So then they could say, oh, I could make this into a function, f of x is equal to 3x squared plus 1. And then you can say, okay, well, what is that doing to the graph, right? Oh, yeah, it's stretching it vertically, and it's all by a factor of 3, and it's also translating the function up 1 unit. They could say something like that, or they could say something about, oh, I changed my function to parentheses x plus 3 close parentheses squared, right? So that function is being translated to the left by 3 units. So a couple of ways that you can really encourage students to refine their descriptions and transformations, thus getting them ready for looking at midlines in trigonometric functions and then later amplitude.